This is the DSCOVR satellite. Just like the great Starship Enterprise, it was sent into space on a 5-year mission. But instead of traveling the galaxies, seeking out new life forms and civilizations, DSCOVR was originally proposed as an Earth observation spacecraft positioned at the Sun-Earth L1 LaGrange Point, providing live video of the sunlit side of the planet through the internet, as well as scientific instruments to study climate change. The Sun-Earth L1 LaGrange Point is a point on the line between center Sun and center Earth where the Sun's gravitational pull is nullified by the Earth's gravitational pull. A NASA publication explains that at L1, the gravitational forces between the Sun and the Earth balance, requiring fewer orbital corrections and therefore reducing fuel consumption for the spacecraft to remain in its operational location for a longer period of time. And that makes perfect sense. It's not hard to grasp this concept. Imagine this green dot as a ball bearing, and the Earth and the Sun as magnets in a 0G setting. If the magnets were equal, then putting the ball bearing perfectly between them would place it in suspended animation. No upward or downward pull, just an equal pull from the left and the right. If the Sun magnet was a little stronger, the point of equilibrium would be closer to the Earth magnet. If the Sun magnet was a lot stronger, then the point of equilibrium would be very close to the Earth magnet. But once the ball bearing was in that sweet spot, you could orbit the Earth magnet around the Sun magnet, and it would orbit right along with the Earth magnet. As for our goal of streaming live video of the Earth over the internet, we landed a tad short. Despite the fact that we were streaming live video from the Moon almost 50 years earlier, NASA sent DSCOVR into space equipped with EPIC, a 4-megapixel camera that, for some reason, can only capture and process one photo every 2 hours. By comparison, Nokia had a 5-megapixel camera on their cell phone in 2007, 8 years earlier. It even had a 3x zoom, while NASA's EPIC has a fixed field of view. Oh, and you didn't have to wait 2 hours between photos with the Nokia. But it is what it is. When NASA released its first photo from the DSCOVR satellite, it was said to be the first real photo of the entire sunlit half of the Earth since the blue marble taken in 1972 by Apollo 17. And despite this new photo once again showing the Earth as a perfect sphere instead of a pear bulging at the equator like Neil deGrasse Tyson describes it, the press was all over this epic achievement. And President Obama even mentioned it. That's right, all those NASA images of Earth from 1972 until 2015, showing different sized continents and color schemes, are all admitted to be composites that are stitched together in photo manipulation programs. As NASA artist Robert Simmons famously said of his 2002 blue marble creation, it's photoshopped, but it has to be. But now, thanks to DSCOVR and EPIC, we're not only getting 12 real photos of Earth every day, we occasionally get to see the Moon pass in front of the Earth, like on July 16th, 2015. But wait a minute. If DSCOVR is at LaGrange Point 1, directly between the Earth and the Sun, and the Moon is directly between DSCOVR and the Earth, then the Moon must also be directly between the Earth and the Sun, which would cause a solar eclipse, right? So why wasn't there a solar eclipse that day? Well, NASA says that since DSCOVR is not exactly on the Sun-Earth line, this transit event is not a solar eclipse. Not on the Sun-Earth line, but doesn't the term Sun-Earth LaGrange Point 1 imply that it's a particular point that is directly on the Sun-Earth line? Apparently a LaGrange point, which made good conceptual sense, is more of a Lagrange general vicinity, which doesn't carry as much credibility. But still, how far off could DSCOVR possibly be? Well, as it turns out, NASA purposely keeps DSCOVR at least 4 degrees away from the Sun-Earth line. What? At 1,000,000 miles from Earth, and a minimum of 4 degrees off the Sun-Earth line, the closest DSCOVR ever comes to the Sun-Earth line is 70,000 miles away from it. That's not even between the Earth and the Sun, let alone at LaGrange Point 1 on the Sun-Earth line. In fact, that's almost 9 entire Earths away from the Sun-Earth line. So while NOAA, who partnered with NASA on this mission, uses this blue cone to imply that Discover is at this white dot representing LaGrange Point 1, they would have been more honest to eliminate the cone, since this is closer to where Discover actually is. And what does it mean that NASA purposely keeps Discover at least 4 degrees away from the Sun-Earth line? Just how far off that line does this satellite go? Well, again, according to NOAA, Discover makes its measurements from the Sun-Earth LaGrange Point 1, which is on the direct line between the Earth and the Sun, and is a neutral gravity point between them. But then they make all of those words meaningless by telling us that Discover orbits this point with an angle varying between 4 and 15 degrees. 15 degrees? Orbit? What exactly is Discover orbiting around? According to NASA, an orbit is a regular, repeating path that one object in space takes around another one. I've sped up this portion of an official NASA visualization showing the many different orbits of their various space satellites, including the Discover satellite at 1,000,000 miles away from the Earth. You'll notice that they do indeed depict Discover in an orbit, but unlike the other satellites that were orbiting the Earth, Discover is orbiting around absolutely nothing. How? By what force is Discover orbiting this empty spot in space? And why? If NASA could have simply parked Discover in a place of equilibrium, as they clearly say they did, so that they could conserve fuel by making fewer orbital corrections, the reason they themselves gave us for parking it there, then what possible advantage could be gained by having Discover circle around the Sun-Earth line in an orbit that ranges from 70,000 to 268,000 miles away from LaGrange Point 1, which is the very point of gravitational equilibrium between the Earth and the Sun, and precisely where Discover needs to be for any of this to make sense? There is no natural force that would make Discover orbit an empty spot in space, which leaves only the force of the thrusters on the satellite, which requires us to accept that propulsion in a vacuum is even possible. But to maintain an orbit, those thrusters would have to be firing virtually non-stop, because a burst from a thruster will send the vehicle moving in a straight line in one direction. But orbits aren't straight lines. They are never-ending curves that form a circle or an ellipse. So almost immediately after thrusting the satellite in this direction, you'd have to thrust it in this direction, and then in this direction, and so on, almost continuously for the 6 years Discover has been out there. How much fuel could this thing possibly have on board? And why even put yourself in that position when you could have simply parked it at LaGrange Point 1 like you said you did? And in what meaningful sense of the word is a vehicle driving around in circles under its own power in orbit? If it is, then these race cars are also orbiting around the center of this track. And it gets even more confounding, because Discover isn't in a simple circular orbit like NASA shows here. It's not even in an elliptical orbit. Nope, according to NASA, Discover is orbiting around the Sun-Earth first LaGrange point in a complex, non-recurring orbit that changes from an ellipse to a circle and back, called a Lissajous orbit. What kind of voodoo spellcraft is this? Apparently Discover's racetrack is more like this one. Alright, so let's examine what they've said. First, they tell us that Discover is parked at L1, a unique location between the Earth and the Sun, hence the name LaGrange Point 1. Then they tell us that an orbit is a regular repeating path that one object takes around another object. And then they tell us that Discover isn't actually at LaGrange Point 1, or even ever actually between the Earth and the Sun, but is instead hundreds of thousands of miles away from the Sun-Earth line in some obscure, non-repeating, parlez-vous français orbit around not another object, but an empty spot in space, which can't sensibly be considered an orbit at all. So they've completely nullified the very meaning and principle of a LaGrange point, the meaning of between the Earth and Sun, and their own definition of what an orbit is. And if Discover can, quote, orbit anywhere from 4 to 15 degrees around an empty spot in space at LaGrange point 1, then why not 20 degrees? Why not 40? Why not 60 degrees, which would have it orbiting right through LaGrange points 4 and 5? Why are these even 3 different LaGrange points instead of one huge LaGrange area? None of this makes sense. And it makes even less sense if we add in the 3 million mile difference in distance they say the Earth is from the Sun during its orbit. It's understandable that if the two masses move closer or farther away from each other, L1, the point of gravitational equilibrium, will change accordingly. But there's no natural force that would cause an object at L1 to move along with L1. The Earth wouldn't drag Discover along with it as it moves farther from the Sun, nor would it push Discover along with it as it moves closer to the Sun. And claiming that Discover is orbiting around L1 instead of being at L1 makes it that much worse. There are many other anomalies associated with this mission, such as how EPIC, which normally can only take one picture every 2 hours, is all of a sudden able to capture a photo every 15 minutes whenever the Moon transits the Earth. And consider this NASA video of a year's worth of EPIC photos. It's been touted in science articles as proof of the Earth's 23.4 degree tilt, the reason for our seasons. But how could it accurately show this tilt when the camera is making 30-degree sweeps, from a 15-degree top-down view to a 15-degree bottom-up view 3 months later? For example, if we're seeing the South Pole due to the 23.4 degree tilt, but EPIC is taking photos from 15 degrees south of the Sun-Earth line, looking up at the Earth from below it, then wouldn't it actually equate to seeing a 38.4 degree tilt? And when EPIC is 15 degrees north of the ecliptic plane, it'd be like seeing only an 8.4 degree tilt, wouldn't it? And the same discrepancies would apply during the months when we're seeing the North Pole. We'd either see up to 15 degrees more of it or less of it, depending on where Discover is at the time. Yet this time-lapse looks like it shows exactly what the heliocentric model calls for if EPIC was directly on the Sun-Earth line at all times. And 15 degrees isn't exactly trivial. It's almost the width of the contiguous United States. And remember, we have to double that because it's actually a 30-degree sweep from the top of Discover's orbit, looking down on the top of the Earth, to the bottom of its orbit, looking up on the bottom of the Earth. So if our natural 23.4 degree tilt results in this view during our summer months, an additional 15 degrees from Discover would look like this. Because at 15 degrees above the Sun-Earth line, EPIC would see a 38.4 degree tilt instead of a 23.4 degree tilt. And that would result in EPIC seeing 15 degrees of the unlit half of the Earth and not being able to see 15 degrees of the lit half. And if Discover is always between 4 and 15 degrees from the Sun-Earth line, then EPIC is always seeing between 4 and 15 degrees of the unlit half and not seeing 4 to 15 degrees of the lit half, no matter which direction off the Sun-Earth line it is. I realize that this video doesn't make an argument either way for the shape of the Earth. I just wanted to point out that the idea that we have a satellite a million miles from Earth performing circus maneuvers around an empty spot in space and sending us a whopping 12 crappy resolution photos a day that don't show us a dang thing that the Google Loon balloon satellites couldn't show us is right up there on the credibility scale with the moon landings, the ISS, and rockets landing backwards onto platforms that are bobbing up and down in the sea. If you are gullible enough to believe any of this nonsense, then their years of indoctrination have worked on you and you have successfully evolved from human to sheep. That being said, during the course of making this video and contemplating LaGrange points, it dawned on me that the very idea of balls in space orbiting other balls in space is bunk, and I'll share my thoughts on that in another video. For now, let me leave you with one of Discover's greatest achievements, this fuzzy photo of Jupiter taken from outer space. Theirs cost hundreds of millions of dollars and is taken through the crystal clear vacuum of space. Compare theirs with mine, which was taken through many miles of dusty, hazy, polluted Arizona atmosphere with a $500 P900. Or with this one, also taken from Earth but with an SCT-8 telescope. Does it seem to you like NASA's giving us our money's worth? God bless, and thanks for watching.